Is salt actually harmful to us, or should we actually be eating more salt? In this video, we're going to look at the evidence and explore if consuming salt in our diet is actually bad for us, so that we should cut down on salt, good for us, so we should actually be eating more salt, or just benign. Now, this is actually a very contentious topic, with a lot of debate and disagreement between studies and between researchers, which has been going on for decades, with some researchers claiming that our salt consumption is too high and that this leads to heart attacks and strokes, and others claiming that actually there's no evidence that cutting down on salt improves health at all, and it might even in fact make it worse. Now, we all know that conventional dietary advice says that eating too much salt can cause high blood pressure, which increases the risk of heart attack and strokes. With dietary guidelines from health services like the National Health Service here in the UK saying that adults should eat no more than 6 grams of salt per day or 2.3 grams of sodium, and other health organisations like the WHO going even further and suggesting less than 5 grams per day of salt. Now, in order to understand where these guidelines come from and if salt intake is bad for us, we're going to have to understand what high blood pressure is, what salt does in the body, and what causes high blood pressure. Now, in this video, we're only going to be talking about primary hypertension and salt. Primary hypertension is high blood pressure that is not caused by obvious underlying health issues like heart disease or kidney failure. So let's first define what high blood pressure is. High blood pressure is defined as a higher than normal pressure in the arteries. You can think of arteries as a bit like a car or bike tyre. If you pump too much air into the tyre, then the pressure will be higher than optimal, which could then lead to damage. This is similar to having too much blood volume in the bloodstream. Now, low blood pressure is also bad as it means reduced blood flow, which can starve your vital organs of oxygen and other nutrients. There are 3 main ways that your body can control the blood pressure: by changing the amount of blood, by constricting or dilating the arteries, or by changing how hard the heart is pumping. When you get your blood pressure measured, you get 2 numbers out. The higher number is the systolic blood pressure, which is the pressure in your arteries while the blood is pumping, and the lower number is the diastolic blood pressure, which is the pressure while the heart is resting between beats. Many factors are thought to contribute to high blood pressure, including metabolic disease, diabetes and obesity, a sedentary lifestyle, stress, smoking, and excessive amounts of alcohol and salt. Essentially, anything that changes the amount of blood, the dilation of the blood vessels, or how hard the heart is pumping will change the blood pressure. And so there is in fact many factors that contribute to high blood pressure beyond just salt intake. Indeed, studies have found exposure to UV light and sessions in a sauna both reduce blood pressure by dilating or widening blood vessels. Dilating blood vessels is also thought to be one of the ways that exercise lowers resting blood pressure. Let's now look at what salt does in the body. Table salt or sodium chloride is made up of 40% sodium and 60% chloride. Both sodium and chloride are essential electrolytes used by the body. Electrolytes are substances that have a positive or negative electrical charge when dissolved in water. Chloride is needed to keep proper balance of the body's fluids and is essential to the function of muscles and nerves. It is also needed for producing the hydrochloric acid used by your stomach for digesting food. Sodium is similarly essential to many body functions, including maintaining the fluid balance, helping muscles to contract, facilitating the transmission of nerve impulses, and aiding nutrient absorption. Many of the body's processes rely on concentration gradients of electrolytes across membranes in order to conduct signals, which is why they're essential in conducting nerve impulses and in muscle contraction. For example, nerve impulses travel along nerve fibers by opening sodium channels in the membrane. This allows sodium ions to flow into the nerve at that point, which then in turn opens sodium channels further along, carrying the signal along the length of the fiber. Indeed, due to the importance of salt and other minerals for health, many herbivores will travel from miles away to lick these essential nutrients from mineral or salt licks, natural deposits of salts and other minerals, in order to supplement their dietary intake. Salt has also been historically important for humans, being important in the development of civilization due to its use for food preservation and seasoning. Salt was a valuable commodity in antiquity, with the word salary coming from the Latin for the word salt. One of the oldest towns in Europe was Solnisata in Bulgaria, which was a salt mine since 5400 BC, producing salt from salt springs. And the town became very wealthy by supplying the salt for much of the modern-day Balkans, and had large fortified walls with many gold objects being discovered at the site. Okay, so we know that salt is important for humans, for animals, and historically important, but how does salt relate to high blood pressure? Electrolytes draw water towards them by a process called osmosis. Osmosis is the movement of water from an area of high concentration to an area of lower concentration through a partially permeable membrane, like is found around human cells. What we mean by a partially permeable membrane is that the electrolytes can't pass through the membrane, but the water can. And so if you increase the salt inside the cell, it would decrease the water concentration, allowing more water to be drawn into the cell through osmosis. And this is an important trick that our bodies use to move water by first moving salt and then the water follows. Now, bodies want to maintain a state of balance or homeostasis, and so it wants to maintain a constant blood volume and constant levels of water and salt. And the main ways in which our body adjusts these is through the kidneys. If the blood volume is too high, then the kidneys increase their excretion of sodium and water, decreasing the blood volume and pressure. If the blood volume is too low, then the kidneys decrease their excretion of sodium and water to try to retain it, maintaining blood volume and pressure. As your body wants to maintain a constant balance between water and electrolytes called osmoregulation, if you consume more salt, then this will lead to you consuming or holding on to more water, and more salt being excreted by the kidneys. Likewise, if you consume too much water, then this will be excreted by the kidneys. And in a healthy individual, these processes should work to maintain a balance. And so the dietary guidelines on salt come from this idea that too much salt, which is one of our main sources of electrolytes, leads to excessive water retention, increasing your blood volume and blood pressure. And indeed, it has been shown in studies that reducing salt intake reduces blood pressure. One meta-analysis of randomized controlled trials looked at studies which included patients with and without hypertension, but no secondary hypertension. The studies compared low and high sodium diets, measured blood pressure, had a duration of at least 4 weeks, and determined the dietary sodium intake from measurements on sodium excretion in the urine. This was a large meta-analysis looking at 85 studies, and they found that the reduction in blood pressure with reducing salt intake was almost linear, with a huge reduction of salt intake from 17.5 grams to nearly 0 grams of salt, causing a large drop in systolic blood pressure. And this is a significant drop in blood pressure, but from a very large drop in salt consumption. However, if we look more closely at the data, those with no hypertension saw only a small change in blood pressure when going from 15 grams of salt per day to 0 grams, which again is a huge drop in salt consumption. As a side note, to convert from sodium intake to salt intake, just multiply the grams of sodium by 2.5, because salt is 40% sodium. Now, realistically, no one is going to be dropping from 15 grams of salt per day to around 0 grams. The average salt consumption in countries like the UK and US is just over 8 grams of salt per day. And so if you were to reduce your salt consumption by a few grams per day, then for people without hypertension, the decrease in blood pressure will be very small, at only around 1%. And so there's no evidence that reducing salt consumption is really beneficial for people with normal blood pressure. And for those with hypertension, it would also only lower the blood pressure by about 2 or 3%. Okay, but if salt caused high blood pressure, then why does cutting salt have such a small effect on blood pressure, particularly for those with normal blood pressure? And why does the high salt consumption of 15 grams per day, which is about double the average consumption in most Western countries, not induce hypertension in those with normal blood pressure? There's clearly a difference between the groups with hypertension and those without hypertension, which means that the group with hypertension is much more sensitive to salt intake than those without. And we're going to come back to what might be causing this difference later in the video. One more interesting thing that the authors did in this study was to split the data up by whether the intervention was a sodium supplement or salt consumed through the diet. Increasing sodium through diet led to a much larger increase in blood pressure compared to increasing sodium through supplementation. And so it's not just the salt itself that can increase blood pressure, but the foods that high salt levels are found in. And in Western countries, we consume most of our salt from processed foods. And so it looks like consuming salty processed foods increase blood pressure a lot more than consuming salt itself. Adding 10 grams of salt from a supplement, which would more than double the average person's salt consumption, only increased systolic blood pressure by about 4 millimeters of mercury, and diastolic by about 2. Whereas the same increase from diet increased systolic and diastolic blood pressure by roughly 10 millimeters of mercury. Now, we've seen that reducing salt intake reduces blood pressure, which should reduce the likelihood of strokes and heart attacks, although the reductions were very small, particularly for those with hypertension. So what data do we have that looks at salt intake and mortality? A 2014 study in the New England Journal of Medicine looked at the sodium and potassium excretion in 102,000 participants, which is a marker for sodium and potassium consumption. They examined the relationship between all-cause mortality and sodium and potassium intake over a 10-year period. What they found was a J-shaped relationship, and that a high sodium intake was associated with increased all-cause mortality. But a low sodium intake was associated with a much larger all-cause mortality. And so consuming less than 3 grams of sodium per day was associated with a large increase in the chance of death. Consuming between 4 and 6 grams of sodium was seen to be the optimal range, and higher than 6 grams of sodium was associated with a small increase in the likelihood of death, with the effect of high sodium being much weaker than that of low sodium. And so it looks like consuming high sodium might be better than low sodium for preventing death. They also found that for potassium, the higher the potassium consumption, the better, all the way up to 4 grams a day, which was the maximum measured in the experiment. These results are also supported by a recent 2024 study, published in the BMC Public Health Journal. The study looked at data from 14,000 participants, looking at dietary recalls to estimate sodium and potassium intake, and then estimated the relationship between these intakes and overall mortality. They found again that high sodium intake was associated with a small increase in mortality, but a low sodium intake was associated with a very large increase in mortality, with the optimal sodium intake being just over 3 grams per day, or 8 grams of salt per day, similar to the average intake in many Western countries. They also found a very similar relationship for potassium intake, with an optimal potassium intake of about 3.5 grams per day. And they looked at the sodium to potassium ratio, with the optimal sodium to potassium ratio being about 1.2 to 1. Now, both of these studies are observational, so they can't tell us if there is a causation between these high levels of sodium consumption and death, only a correlation. We may expect that higher salt consumption might lead to increased mortality, either by increasing blood pressure, or because the higher salt consumptions are likely caused by eating more processed foods, which may negatively impact health. But why would low salt consumption lead to increased mortality? One possible explanation is that those who had low salt and potassium intakes were malnourished and weren't consuming enough food. But is there a possible mechanism that could cause low salt intake to increase deaths? When salt intake is low, the body must work to conserve salt. Low salt diets have been seen to activate the renin-angiotensin-aldosterone system, or RAS, which is activated when blood volume or pressure drops. When the RAS is activated, it leads to excretion of renin from the kidney, which signals to the liver to release angiotensin 1, which is then converted to angiotensin 2. Angiotensin 2 has 5 main effects. It causes constriction of blood vessels, reducing their volume and increasing blood pressure. It signals for antidiuretic hormone to be released from the hypothalamus in the brain, which decreases water excretion in the kidney. It causes aldosterone to be released from the adrenal glands, and together, angiotensin 2 and aldosterone act on the kidney to increase sodium and water reabsorption. Angiotensin also increases the activity of your sympathetic nervous system, that is the part of your nervous system responsible for the fight or flight response. And according to one meta-analysis, salt-restricted diets have been seen to slightly increase your heart rate, as well as increasing stress hormones like adrenaline and noradrenaline, and blood cholesterol and fat. Increased levels of all these factors are associated with increased mortality. Another review showed that low-salt diets increase insulin resistance, leading to elevated insulin levels and worsened blood sugar control. Insulin resistance is thought to be the underlying disorder of the metabolic syndrome, which links together obesity, diabetes, abnormal cholesterol, and high blood pressure. It is thought that elevated levels of insulin on a low-salt diet are a compensatory mechanism to help the kidney hold on to sodium. And so there's plausible mechanisms by which restricting salt consumption may actually harm health. And so this large increase in mortality risk for low salt consumption may actually be a real effect. This means that the benefits from restricting salt on blood pressure are likely outweighed by the negatives for most people, particularly for those with normal blood pressure. And it has even been seen that sodium restriction in patients with heart failure was actually associated with an increased rather than decreased risk of death. Also, more than half of those with hypertension don't have blood pressure that is sensitive to their salt intake. And so, if salt doesn't seem to cause hypertension, and reducing salt intake might be harmful, then what other factors could be causing hypertension that we should address instead? Now, I mentioned earlier that it's well known that there are many other factors that contribute to hypertension, including metabolic disease, diabetes and obesity, a sedentary lifestyle, stress, smoking, and excessive amounts of alcohol, as well as insulin resistance. It is estimated that roughly 80% of those with hypertension are insulin resistant, and diabetics have a higher likelihood of hypertension than non-diabetics. A detailed 2024 review article looked at the link between diet and insulin resistance and hypertension. The authors outlined how excessive consumption of fructose, omega-6 fats, and grains, combined with insufficient exercise, all lead to insulin resistance. Fructose is the main sugar found in fruit, but in a Western diet, most of our fructose comes from high fructose corn syrup and sucrose, which is table sugar, and is half fructose and half glucose. Omega-6 fats are polyunsaturated fats found in high concentrations in vegetable oils, like sunflower, canola, and soybean oils. Now, I won't go into detail on how each of these causes insulin resistance, but the paper is open access, and so if anyone wants to read for themselves, then it will be linked below. But the authors argue that these four main factors lead to insulin resistance, and that they cause hypertension by worsening blood vessel function, which leads to constricted blood vessels and higher blood pressure, and also acts by causing excessive retention of sodium and water. And so your blood pressure is elevated as you have narrower blood vessels combined with more liquid in the body. In insulin resistance, tissues that would normally respond to insulin, like the muscles, liver, or fat, become less responsive. This leads to increased insulin levels in order to prevent blood sugar from rising. However, the cells in the kidney remain sensitive to insulin, and increased insulin levels stimulate the kidney to retain more sodium. This hampers the body's ability to excrete sodium, leading to increased sodium and increased water, and therefore increased blood pressure. Insulin is also the hormone that tells your body to store calories, and so elevated insulin levels can actually lead to you gaining more body fat, which could be an unwanted and unexpected side effect of lowering your salt consumption. Eating carbohydrates stimulates insulin more than fats or proteins, and it's been seen that low carbohydrate diets can lead to large reductions in insulin, blood sugar, and blood pressure, with one study in a UK general practice with 19 patients showing a reduction in systolic blood pressure by 50 millimeters of mercury over an 8-month period. Due to the lower insulin levels on a low carbohydrate diet, some may actually need to consume more salt than normal as they're excreting it more easily. And losing too much salt when starting a low carbohydrate diet is thought to cause what is called the keto flu. One meta-analysis found that resistance training 3 times per week significantly reduced blood pressure in hypertensive and pre-hypertensive individuals, with a reduction in systolic pressure of 8 millimeters of mercury for studies lasting between 8 and 16 weeks. And so, clearly diet and exercise together can greatly improve blood pressure, while also improving health in general, and have a much larger effect than salt restriction. And so to wrap up, it looks like salt is an important nutrient that has been wrongly vilified for causing high blood pressure. Cutting down salt has a very small impact on blood pressure for most people, and probably actually causes more harm than benefit. While doing the research for this video, I found a lot of scientific papers that were really questioning the dietary guidelines from health agencies, as these guidelines seem to have a complete lack of evidence from randomized controlled trials, which are considered the top tier of evidence, to support that cutting salt would actually be beneficial to most people. And yet, despite not having the evidence, they go ahead and suggest the guidelines anyway, which I find very confusing, as surely, before recommending guidelines to billions of people, you should at least have hard evidence proving that there's benefit and no harm to them. And it seems to me from my research that it isn't salt intake that is the problem, but the body's ability to regulate its blood pressure and remove excess salt and water, and dilate the blood vessels that is the main cause of hypertension. And so it isn't dietary salt that's causing hypertension, but bad diet, a lack of exercise, and other lifestyle factors like alcohol, smoking, and so on. And so hypertension is really caused by the same things as insulin resistance, type 2 diabetes, obesity, and the rest of the metabolic syndrome. And we've seen that a low carbohydrate diet with reduced consumption of grains, sugar, and omega-6 rich vegetable oils led to large reductions in blood pressure. We saw that exercise also improves blood pressure by improving circulation and metabolic health. And even other lifestyle factors like exposure to UV light and spending time in a sauna improved blood pressure by dilating blood vessels and improving circulation. And I think what the evidence says is that we shouldn't worry about our salt consumption, and we can happily salt our food to taste. And in fact, many of us might actually want to increase rather than reduce our salt consumption, with optimal salt consumptions being estimated between 8 and 15 grams per day. But what we should worry about are processed foods and our general diet and lifestyle. For more great informative content, check out the rest of my videos. And if you want to support the channel, you can do so via PayPal or Buy Me a Coffee, which will be linked in the description below.